of equations that you solve by graphing. There are three ways to solve a system. You can do it by graphing, by elimination, and by substitution. You have to know all three. My favorite is the third elimination. With a system, what that means is you have just more than one equation. You have more than one at a time that you're working with. So you need to worry about solving these. And the way you do that, you can, however you want, you can start an XY table, but you have to do one for each equation. An XY table for each equation. And you're going to pick some values. It does not matter what you pick to be your X coordinate, because your Y will be dependent on that. I'll go with -1, 0, and 1 here. I'll go with -3, 0, and +3 here. Okay, you just pick whatever you want. These are just the numbers I chose. Alright, so this is the first one. This is my Y equals 2x plus 1. This is my Y equals x plus 3. Well, when x is -1, 2 times -1 is -2. -2 plus 1, -1. You just plug it in, the x value for x in the equation. When x is 0, 2 times 0 is 0. 0 plus 1 is 1. 2 times 1 is 2. 2 plus 1 is 3. Okay? And when you have this one, now you have a different equation. -3 is your x. -3 plus 3 is 0. 0 plus 3 is 3. 3 plus 3 is 6. Okay? So now you're ready to make your graphs. And I'm going to use a few different colors here for this.
You can't see the same X, Y, Y, X, Y. Let's see the first one.
Can you see it now?
Now,
I'll just do it at the bottom.
the next step. Okay, that's it.
I'll just do it here. Alright.
And what was it? Y equals what?
X plus 3. Alright. So,
Okay.
now we have that. No problem. We have that. So, you need to graph what you have. I'm going to start with the first equation here. The y equals 2x plus 1. My first pair or coordinate point was -1, -1. This is 0, 1. This is 1, 3. Start at the origin. Over 1 to the left, down 1. That's the point. -1, -1.
Oh, come on.
It takes all of this. 0, 1. Start at the origin. Go up 1. The next one. Over 1. Up here. That was 0, 1. This was 1, 3. And I can't draw that well, sorry. So you connect your dots as such. This is the line y equals 2x plus 1. The next equation, I'm going to do it in blue. Y equals x plus 3. So now you have -3, 0, 0, 3, and 3, 6. I'm going to grab those. -3, 0 is here. 0, 3 is here. 3, 6 is up here. And I'm going to draw a line connecting those. And this is y equals x plus 3. Now, what happens here you have still not found that solution point. So what is probably beneficial to you, because you can see the lines are beginning to coincide. They're beginning to get closer. You pick more numbers that help them. Okay, you have to pick more numbers to make your values true. And I'll give you an example of one that for sure will show that to you. Okay? Alright. What if I have y equals negative x plus 2 and y equals x plus 3? I want to go ahead and graph these. But before you can graph them, you have to be able to do the points. Alright, so XY table, I promise you, make things a lot easier, especially when we get into more in-depth math. Okay? Now, pick your three values, random numbers. I'm gonna go with -3, 0, and 5. Here I'm gonna go with maybe -4, 0, and 1. I always like to pick 0 because what 0 does is it always gives you the y-intercept. So when x is -3, that's like saying -3 plus 2. Negative times a negative is a positive. So -3 is +3 plus 2 is 5. Plug in 0. Now 0 does not take the sign of a positive or negative. 0 plus 2 is 2. Plug in the 5. -5 plus 2 is -3. 5, 2, and -3. Here, -4 plus 3 is -1. 0 plus 3 is 3. 1 plus 3 is 4. So now what you have are your ordered things. -3, 5, 0, 2, 5, -3. Here you have -4, -1. Here you have 0, 3. Here you have 1, 4. Those are your points. Okay? So, you have the points. Now it's time to graph. Alright, so it's time to graph. -3, 5. So at the origin, 1, 2, 3, 1, 2, 3, 4, 5. Okay? So that's -3, 5 here. 0, 2. So at the origin at 0, go up 2. 0, 2. 5, -3. 1, 2, 3, 4, 5. 1, 2, 3. 5, -3 is 3. Connect your points with a line. Alright, connect your points with a line. And that's the equation. Y equals -x plus 2. Next equation. The y equals x plus 3. -4, 1. -4, -1. That's here. -4, -1. Like that. 0, 3 is the next point. 0, 3 is here. This one is at 1, 4. 1, 4. And you connect these little lines. Alright, connect those little lines. So now what you should notice is a clear point of intersection in this area. That point of intersection is your solution. Okay? It is at the point, kind of in between. But that could be because of my bad drawing, I promise. It looks like it's about 1/2, 2 1/2. 1/2, 2 1/2. That lets me know that when I plug that in, that will be my answers here. Okay? And I can prove that. Erase these. Or negative 1/2 round, because it's in the second quadrant. So I'm saying that y is 2 1/2, because that's what I got from here, equals negative 1/2 plus 2. Well, you can't have negative negative. So that becomes positive 1/2 plus 2, which equals 2 1/2. So yeah, that does work for this. That's fine. Let's see if it works here. I'm still saying that y is 2 1/2 equals, I said x was negative 1/2 plus 3. Well, yes, negative 1/2 plus 3 is 2 1/2. So this checks out. The way you notate it, the solution to this is negative 1/2, and you'll probably see 5/2, which is another way of writing 2 1/2. Multiply the denominator times the whole number. 2 times 2 is 4, and the numerator to get 5. Keep the same denominator. Okay? So with graphing, yes, it does take some work. It takes some work. It's not my favorite method because, like with this show, and when you're doing it, you have to be very careful. You can mistake points. You can think they're somewhere, but they're not actually in that exact spot. So just take your time and be careful when doing graphing of equations. Okay? Then you'll get situations like this sometimes. We have to graph. That's a line, and maybe this is a line. When you are given two parallel lines like this, parallel by definition lets me know they will never intersect. Okay, parallel never intersects. Well, if those lines never touch, there will never be a spot where the answers can be the same. So parallel lines or lines like this are what we call lines that have no solution. There is no answer that will ever make them work. Okay, because the equations either cancel each other out, okay, or just don't work right. Then sometimes you'll get situations where you have to graph. Maybe line A was like this. I'll call it line A. Okay, I'll call that line A. Well, maybe line B was exactly like line A. When that happens, it is what is called infinitely many solutions. That is infinitely many solutions. It does not matter what you plug in. If you plug in x equals 1 right here, well, they're both still have the same answer. If I say x is negative 5 over here, they both have the same answer. So no matter what you choose, those are two cases that are very, very, very important. Okay, if the lines intersect completely, well, they always are on top of each other, infinitely many. If the lines never touch, it is what is called no solution because they're parallel. We're going to try graphing this. Next line. Our system. get the markers. Alright. I'm going to tell you that we're going to work with x plus y equals 4 and y minus 1 equals, no, that was 2 more. Okay, something like this. Okay, these are two different equations. Now, sometimes you won't even have to do all the graphs. They'll give you a situation. Is negative 1, 3 a solution? Is negative 1, 3 a solution? Would negative 1, 3 make this true? Would it make it false? You just plug the stuff in. I'm going to rewrite my equations using what I was given. X is negative 1, because the point's always written, x, comma, y. So, x, negative 1, plus y is 3, equals 4. Here I have y is 3, equals, well, x is negative 1, plus 0. Negative 1 plus 3 is 2. 2 is not equal to 4. Here, 3 is equal to negative 1. That is also false. So what that tells me is that negative 1, 3 is not a solution because the values were not true. Negative 1, 3 cannot be a solution. What if I change my number? Is 2, 2 a solution? Is 2, 2 a solution? Take the system and try it out. X is 2 plus y is 2 equal to 4. Here I have y is 2 equal to 2 plus 0. Well, 2 plus 2 is 4. 4 is equal to 4. So yes, that works. But it must work for both equations. Let me try the second one. 2 plus 0 is 2. 2 equals 2. Yeah, that works. So 2, 2 is a solution. That is true. 2, 2 does work. That means if I were to graph these lines at the point 2, 2, they should intersect. But we're going to work through that and make sure we can. This will be my last graphing problem, and I'll move on to the next time. With graphing, it is important to make the x, y table. So we're going to go ahead and do that. Okay. X, y. And this will be for x plus y equal to 4. Let me do this one first. And I want to pick some numbers. I'm going to go with negative 1, 0, and 2. When x is negative 1, what is y to be 4? So you have the equation. Negative 1 plus y equals 4. Here I have 0 plus y equals 4. Here I have 2 plus y equals 4. Then this becomes a matter of solving equations. Do the first one. Negative 1 plus y equals 4. I want to get y by itself. Get rid of negative 1. You add 1. Add 1. So y equals 5. So if x is negative 1, y is 5. Here, so this is kind of a no-brainer. 0 plus what number equals 4? 4. 0 plus 4 is 4. Here, 2 plus 2 equals 4. So now I have my points for the first equation. Go ahead and draw that one out before I erase it. Alright. Negative 1, 5. Negative 1, 1, 2, 3, 4, 5. 0, 4. 2, 2. 1, 2, and 2. Now I'm going to go ahead and connect the dots just with a different color to keep it separate. Alright. Please excuse my grammar. It's not good. So this is the equation x plus y equals 4. But remember, systems are not just one equation. It's more than one. So I'm going to move on to the next one. And that is y equals x. I'm leaving off the plus 0 because it doesn't make a difference. So y equals x. I'm going to go with negative 3, 0, and 2. Well, when x is negative 3, y is negative 3. When x is 0, y is 0. When x is 2, y is 2. It's a matter of graphing those points. Negative 3, negative 3. Negative 3, 1, 2, 3 is here. 0, 0 is here. 2, 2. See how they both lie on this point. Both lines hit the point 2, 2. That is what graphing a system will show you when you get to the solution. That is what it will show you. I just cannot draw straight. I tried my hardest, okay? It doesn't work. Okay? Do your graphing on section 1 of the new chapter. Okay? Then there's 10.2. 10.2 is solving a system by substitution. This is a way that is typically left out of the grade school curriculum just because students struggle with it so much. But I like it. It's not my favorite, but it does work when done properly. It is the method of choice if maybe graphing is not your forte. Or if when I get to the other one, you just don't understand what I mean. Okay. Let me give you two equations. Y equals 3x. Y equals x plus 8. Okay? You have y equals 3x. You have y equals x plus 8. Yes, you could graph these. You could definitely do it. You could make a line showing 3x using the XYZ table. You could make a line using x plus 8 using that. But substitution is a good method here. First, when you substitute, step 1, you have to decide which variable you want to solve for. Which variable to solve for. Are you trying to figure out x? Are you trying to figure out y? I'm going to go ahead and figure out x. Okay? So here I'm going to solve for x. To solve for x, I have to get rid of y. So right now, I have these equations. Y equals 3x, and I have y equals x plus 8, and I want to get x. Okay, let's be decided. That's step 1. Step 2. Substitute the variable from step 1 into the other variable's location. Okay? By this, the variable I want is my x. That means I have to put x in where y is. The important equation here is this one. Y is the same thing as 3x. The exact same thing. That's like saying 2 is the same thing as 10 divided by 5. It's the same thing. So, if this y equals x plus 8, well, using the logic from this, if y can equal this, so can 3x. So instead of this y here, I'm going to say, well, now 3x equals x plus 8. Because y and 3x are the same thing. I'm getting rid of the y, and I'm plugging the 3x in for it. Step 3, now you're ready to solve. Okay, solve for variables. Solve for the variable that you now want. I want this one. Well, to solve this equation, 3x equals x plus 8. Subtract x from both sides. 3x minus x is 2x. So 2x equals 8. Divide by 2. X equals 4. X equals 4. I have figured out what one of my variables is. I now know that x must be equal to 4 because of substitution. But that's not the whole point. A point consists of x and y. So now you have to figure out y, which is a lot easier than people think it is. Step 4. Solve for other variable using the answer from step 3. Solve for the other variable by using the variable from step 3, using the answer from step 3. Step 3 told me that x was equal to 4. Okay? Plug that in into one of these equations. Plug in to one of the given equations. Plug that in to one of the given equations. I'm going to use the top. Y equals 3x. Well, I know that x is 4. So I'm going to plug in x is 4. Well, y must be 12. Because 3 times 4 is 12. So now you have your solution. Your solution to this is 4, 12. And you can prove that. 3 times 4 is 12. X is 4. 4 plus 8 is also 12. So you know that it works. We'll try another substitution. Alright, 2y equals x plus 4, x equals 3y. Choose what you want to solve for. Okay? I'm going to decide to solve for y this time. Okay, so I'm going to solve for y. So to solve for y, I must eliminate x. So I'm going to rewrite my two equations. I have 2y equals x plus 4, and I have x equals 3y. Well, I'm trying to eliminate x. I want, this one is in simpler form. So this is also going to be the one you're going to do your substituting. Okay, you're going to be switching stuff out because of this. Well, I want to get rid of this x. X is the same thing as 3y. Oh, so if that's the case, then I can use 3y instead of x. They are the same thing. Plus 4, and just carry everything over. Now I have an equation I can solve because the variables are the same. Subtract 3y, subtract 3y. That's negative 1y equals 4. Divide by negative 1, y equals 4. Okay? Y equals 4. I'm going to pick this equation to test and see what's x. Now I'm ready to solve for x. X equals 3y. I know that y is 4 from the work I just did. I'm plugging in a 4, a 3. X equals that. 3 times 4 is 12. So x is equal to 12. So when I do my answer is 12, 4. Remember, x must always come before y. Okay? That's how you substitute. You just switch things in until it makes sense, until you have one variable that you can solve for. I did 2 examples. I did one where you solve for y, eliminated x, one where you solve for x to eliminate y. But sometimes you won't get this simple. I'm not going to do a whole other example, just showing you in case you get a situation like this. What if you're given 5y equals x plus 8 and y equals y minus 2x equals 6? Neither one of these can easily be just pushed into an equation because neither one has a variable on a side by itself. Then that becomes your duty to do that. And you can do it with whatever you chose to. Let's say I want to get y by itself on both of them. I want to solve for y. I want to solve for y. I'm going to start at the top. 5y equals x plus 8. To get y by itself, I must divide 5. So y equals x plus 8 divided by 5. Now, this isn't a pretty one because it gets kind of difficult when you try to substitute with fractions. It does get difficult. Let's try this. Y minus 2x equals 6. Y still isn't by itself. So I need to add 2x to both sides. So now I have y equals 2x plus 6. Or you could write y equals 6 plus 2x. It's the exact same thing. Okay? So these are now, these are easier to substitute than this would be a substitute. Okay? You would just plug this stuff in now instead of trying to plug that. Alright. My favorite, 10.3. Solving systems by elimination. With the keyword being elimination. You eliminate one variable at a time. By eliminating, answers become easier to find. Let's say I had the system x plus y equals 5. X minus y equals 1. Okay, x plus y equals 5. X minus y equals 1. And I want to solve this using elimination. There are a series of steps to take here. Step 1. Choose a variable to solve for. Choose a variable to solve for, or choose one to eliminate. Now, notice something here. I have a positive y and a negative y. Just like with a positive number and the same number just with a negative sign, they easily cancel out. So do variables. So I'm going to, in this case, I'm going to choose to solve for y, thereby eliminating x. I'm sorry, I wrote it the wrong way. I'm solving for x, and I'm going to eliminate y. Y is ready to be eliminated. Same thing, exactly the same, different signs, perfect. This is the opportune time to use the elimination method. What you do, you set these equal to each other. Okay? Now, there's an understood one here, just like there's an understood one here. This one is understood to be positive. Understood. 1x plus 1x is 2x. Y minus y cancels nothing. 5 plus 1 is 6. Okay? What I just did here was step 2. Cancel variable. Now, this step 2 depends on the difficulty of the problem. This one was an easy one because I didn't have to do any extra work. It was already given to me in good form. So now I have 2x equals 6. I'm going to divide by 2, divide by 2, x equals 3. I have counted out my y's and just did step 3. Solve for remaining variable. Then there's step 4. Solve for the other variable. Solve for the other variable. I know that x is equal to 3. The equations we just had, x plus y equals 5, and x minus y equals 1. Choose one. Choose one. I'm going to go with this one. All right? So I know that x plus y equals 5. I also know from the other word that x was equal to 3. So 3 plus y equals 5. Subtract 3, subtract 3. 5 minus 3 is 2. So now I have solved using elimination. 3, 2 is my solution. And you can test to see if it works. 3 plus 2 equals 5. That works. 3 minus 2 equals 1. That works as well. So you know that is a given solution that does work properly. Try that. All right. This is about as hard as it's going to get, okay? So I'm going to go through this one really slowly. Nothing here is ready to be canceled out. Nothing. You have 4x and x. That doesn't do anything. 2y and y, can't combine them like that. What you need to do is say, well, what can I eliminate? Let's say that I want to eliminate y. I'm going to eliminate y. I have 2y and I have 1y. Because you know there's an understood one here and an understood one here. Both of which are positive. In order to eliminate y, I have to have a negative number and a positive number. And both of these numbers must be the same. Only difference, one is negative, one is positive. You find what is called the LCM. That goes back to the original math part 1, so I'm assuming you already know this. The LCM, the least common multiple, out of 2 and 1. Well, the least common multiple out of 2 and 1 is 2. I already have a 2 here, so I'm good. I'm going to leave this top equation alone because it has what I needed to have. It's the second one that needs some work. And I have my positive number. This is my positive. So to cancel out, this must become my negative. I have a positive 2y. So what I need to cancel it out? A negative 2y. That would let me eliminate it, okay? Elimination. To get from 1y to negative 2y, I would have to multiply 1 by negative 2. So I have to do that to the whole equation. You can't just do it to one part. You cannot do it to one part. You have to do it to the entire thing. Negative 2 times 1x is negative 2x. Negative 2 times 1y is negative 2y. Negative 2 times 3 is negative 6. This is eliminated. 4x minus 2x is 2x. 8 minus 6 is 2. I divide by 2. I divide by 2. X equals 1. But you know that's not enough. We still have to figure out, well, what is y? So I'm going to pick one of these equations. I'm going to go with the easier one. The one that was x plus y equals 3. I know that x is 1. So 1 plus y equals 3. Subtract 1 from each side. Y equals 2. So my answer here is the order pair of 1, 2. When x is 1 and y is 2, this is true. And we can prove that. I know that x is 1, I'll plug in a 1. This is using my original equation. Plus 2 times 2. And I said it was equal to 8. 4 times 1 is 4. 2 times 2 is 4. And that certainly equals 8. And I already tried it here. 1 plus 2 is 3. So that's how you solve using elimination. I'll do one more. Because sometimes you'll get problems that aren't even in that easy of order. And it's your job to fix that. Okay? Now, you have to decide which variable you want to eliminate. I'm going to go ahead and eliminate my x's this time. Okay, I'm going to choose to eliminate my x. Well, I have a 5x and I have a 2x. Remember, one must be positive, one must be negative. Using the LCM. Well, the least common multiple between 5 and 2 is 10. So that means one of these has to be a 10x, one has to be a negative 10x. Does not matter which one is positive and which one is negative. That has no bearing on the math. I'm going to decide to go ahead and make the top one my negative. So I'm going to multiply this 5 to 10. I'm making my positive. 5 to 10, that means I have to multiply it by 2. This one, 2x to negative 10x, I need to multiply it by negative 5. 2 times 5x is 10x. 2 times 3y is 6y. 2 times 19 is 30. Negative 5 times 2x is negative 10x. Negative 5 times 4y is negative 20y. Negative 5 times 17 is negative 85. My x's have canceled. 6y minus 20y is negative 14y. 38 minus 85 47. Let me check this out. Because I could make a mistake. It's very possible. Okay, yes. It's 47. Okay? So y equals 47 over negative 14. You won't have anything this difficult, but you should be aware of how to figure out your answers. I suggest when given fractions as answers that you re-solve the problem for the other variable. I have 5x plus 3y equals 19. 2x plus 4y equals 17. This time I want to eliminate y. I have 3y, I have 4y. Well, the least common multiple is 12. So I need one 12y, I need one negative 12y. That's up to you. I'm going to multiply this one by 4. 4 times 3 will give me the 12. I'm going to multiply this one by negative 3. Negative 3 times 4 will give me the negative 12. Negative 4 times 5. 4 times 5 is 28. 5x. 4 times 3y is 12y. 4 times 19 is 76. Negative 3 times 2x is negative 6x. Negative 3 times 4y is negative 12y. Negative 3 times 17 is negative 51. If, after you do this, something does not eliminate, you messed up. Just simply start over and see what occurred. That cancels. 20 minus 16 is 14x. 76 minus 51 is 25. Divide by 14, divide by 14. X equals 25 over 14. So you have found both of your solutions. Okay? Watch this video because elimination does take work. All of them take work. Okay? Work on your homework. I will see you again on Thursday.